Objective 3, finding the remaining zeros. Let's suppose we have a function f of x equals x cubed plus 2x squared minus 13x plus 10. Suppose it's given that x equals 1 is a 0. There's something called the factor theorem that says x equals c is a 0 of p of x. What does that mean? That means that p of c equals 0 if and only if x minus c is a factor. Now, I told you x equals 1 is a 0. You can check that. P of 1 is equal to 1 cubed plus 2 times 1 squared minus 13 times 1 plus 10. That's equal to 1 plus 2 minus 13 plus 10, which adds up to 0 as promised. Now, the consequence of this is x minus 1 is a factor. So we've begun the factorization process by finding what makes the polynomial 0. Let's go ahead and divide it out. You divide 1 using synthetic division, or you could just grab that 0. And we're going to divide 1 into 1, 2, negative 13, 10. Those are just the coefficients of this third degree polynomial. Bring the 1 down, multiply, add, multiply, add, multiply, add. It's a good thing we got 0. That checks that validates this process. Now, this is a second degree polynomial, x squared plus 3x minus 10. We could continue synthetic division, but this is a quadratic. You could set this equal to 0 and factor, and it gives you x plus 5, x minus 2 equals 0, and we get x equals negative 5, x equals 2. Now we can summarize this as far as zeros. We have x equals 1. That's the original one. We also have x equals 2 and x equals negative 5. Now the factorization, of course, we've completely factored this polynomial. We have x minus 1. X equals 2 corresponds to a factor of x minus 2. And x equals negative 5 corresponds to a factor of x plus 5. So we've completely factored the polynomial. We can also draw a rough graph. We have, there's y, there's x. And we have zeros at 1, 2, and also negative 5. And you can plug in a number like 3, and you can plug 3 in here. See, it's going to be plus, 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 going to be positive, going to be up here somewhere. These are all single factors. Guess what? It just goes through the axes. Doesn't do twisty-turny inflection point thing, and it doesn't bounce off. It doesn't go parabolic in a local sense. So it starts up here. It just goes through the axes, and then through the axes. And that's the graph. So let's look at another example. Let's suppose we have f of x equals x to the fourth plus 2x cubed minus 13x squared plus 10x, and x equals 1 is a 0. You'll notice in this case, x is present in every term. You could first of all factor out x, and we get x cubed plus 2x squared minus 13x plus 10. This gives us x equals 0. Now this one we've already done. X equals 1, x equals 2, x equals -5. And so, of course, the a complete factorization is going to be f of x equals, well, just x, x minus 1, x minus 2, x plus 5. And then we're all finished. This is a fourth degree function. You could simply add a 0 here and it would look similar but not the same. Very easy to graph. Simply come through and do that. Remember what we said about an even degree polynomial, fourth degree, same behavior on the ends. Okay, goes up here, goes up here. That's pretty evident when you put it in factored form. If you have 4 factors, guess what? It goes through once, twice, 3 times, 4 times, has to end up going back from where it came, which in this case is up to positive infinity. Okay, that's all for objective 3.